In this tutorial, we will be discussing combustion reactions. Combustion reactions are a form of redox. And just as a reminder, redox stands for oxidation and reduction. Oxidized atoms are those that lose electrons, while reduced atoms are those that gain electrons. If we think about the number line again, 0, plus 1, plus 2, negative 1, negative 2. Remember, electrons are a negative charge. So if you lose electrons, you're losing negative charges. So you're becoming more positive. So oxidized atoms are becoming more positive, meaning that they're going to the right on the number line. Reduced atoms are gaining electrons, so they're gaining negative charges, which is making them more negative. Which means that they're going left on the number line. Here's our mnemonic device, GER, gain electrons reduced, LEO, lose electrons oxidized. Reactions in which the oxygen is the reactant, is one of the reactants, is called a combustion reaction. Combustion reactions release a lot of energy, which is why we're able to use things like combustion reactions for gasoline in cars. Combustion reactions are a subclass of oxidation reduction reactions. This here is an example of a combustion reaction. Notice it has to have oxygen as one of its reactants. So how exactly do you predict the products of these combustion reactions? Well, it all depends on what your starting materials are and how that they're going to bind up with oxygen. So when we're looking at a compound, for instance here we have C8H18. So C8H18 plus oxygen. We want to examine this compound. We want to break it down to those elements. So we have carbon. So here's carbon. It's going to make carbon dioxide. And we have hydrogen. And hydrogen is going to form H2O. And so what you're going to want to do is match up the other reactant with what it would possibly produce. Let's take a look at this. Write an equation of a complete combustion of CH3OH. So let's say we have CH3OH and reacting it with oxygen because it's a combustion reaction. I know I have carbon, so that's going to form CO2, and I have hydrogen here. That's going to create H2O, and then the oxygen is negligible since we're reacting it with oxygen. So CO2 and H2O are going to be our products. And from here, you're just going to balance it. So we have C, H, and O as our elements. We have one carbon on the left, one on the right, 4 hydrogens, but 2 on the left, so let's multiply that by 2. We have 3 oxygens on the left. We have 2 here, we have 2 here, so we have 4. Now when we look at the left-hand side, we have an oxygen that's already built into it. There's no way that I'm going to make this to work out unless I make this into an even number. So I'm going to multiply that by 2 and try again. 2, 2. That changes my oxygens to 2 times 2 plus 2 is 6. Changes my hydrogens over here. I have 6 here. I have 2 more here, so I have 8 on the right, on the left. And I change my oxygens then. I have 2 here and 2 here, so I have 4. Alright, so let's fix our hydrogens now. We have 8 on the left, multiply this by 4 to make 8 on the right. In the process, that changed my oxygens. So I now have 4 oxygens over here, which means I have 8 total. We have 2 here still from the CO2, and now we have 4 from the H2O. When we look over here, we have 2 oxygens embedded in this reactant. So we have 8 minus 2 on the left. I need to get 6 out of here now, and that's where I get the 3 from. Combustion ones are probably one of the hardest reactions to actually balance. So keep that in mind. Take your time. Alright, acetic acid, HC2H3O2, combustion, meaning I have to react it with oxygen. First thing I need to do is figure out what my products are. I have carbon and I have hydrogen. Carbon becomes CO2, hydrogen becomes H2O, and then the oxygen I ignore. Alright, so I have 2 carbons on the left. I can put 2 on the right. I have 3 and another hydrogen in there to make 4. So I'm going to multiply this by 2. Now let's balance the oxygens. We have 4 here. We have 2 here, making 6. Over here I have already 2 that are embedded in the compound. So 6 minus 2 equals 4. I need 2 more oxygens. One last example. C3H7OH. Combustion, so I'm reacting it with oxygen. My products, I have carbon making CO2, and I have hydrogen making H2O. Okay, now let's try to balance this. This one's going to be a little bit more difficult. C, H, and O. I have 3 on the left, 1 on the right, 8 on the left, 2 on the right, and 2 and 1 here, so I have 3 on the left, and 2, 3 on the right. Start at the carbon. Multiply this by 3 to change the carbons to a 3. That changes our oxygens to 6, which brings us grand total up to 7. Hydrogens, we have 8 on the left, 2 on the right, so I can multiply this by 4 to make 8. And that brings my oxygen over here up to 4, which brings my grand total up to 10. Now I have 1 embedded, so 10 minus 1 is 9. There's no way I'm going to make 9 oxygens out of this because it has to be an even number when I'm done. So I can multiply this by 9 halves and then multiply everything by 2. So it becomes 2 C3H7OH. The 2 in the 9 halves and the 2 in the front cancel out to be 9. That 3 times 2 is 6, and the 4 times 2 is 8. And that's how you do combustion reactions in predicting the products.